Okay, in this video, we're going to talk about division with exponents. We're also going to talk about a couple related rules. Most notably, we're going to talk about the zero exponent rule, and definitely we're going to talk about some of the negative exponent rules as well. I'll probably take a separate video to really delve into the negative exponents, because simplifying negative exponents, it takes some practice. So whenever we're dividing terms with exponents, it's important to note that the main rule that we use is something called the quotient rule. And the quotient rule is this. Anytime you're dividing, again, it's got to be the same base, so x and x to the a over x to the b is going to be x to the a minus b. Now, I have a corollary to this, and we're going to show you that in a little bit, but let's start right here. So if I've got, say, x to the 7th power over x squared, this is going to be x to the 7 minus 2, this is going to be x to the 5th. And our reasoning behind that is this is essentially just like a fraction. We're going to have x times, pause for a second. Okay, so when we're doing this, this is x to the 7th, so it's x times x times x times x times x times x times x, all over x to the 2nd, so x times x, and we're gonna reduce this just like we would a fraction. Anytime I've got two terms that are the same, I am essentially dividing them out. X divided by x is 1, and I can do that, looks like 2 times. So I'll have 1 times 1 times x times x times x times x times x times, well, I'll have x to the 5th over 1. And that's that. Now, I did say we've got a couple kind of corollary rules here. Now, you'll notice that I've got more x's on the top than I do on the bottom. So here is kind of that first corollary. If I've got a higher exponent in the denominator, I'm going to be left with a term not in the numerator, but in the denominator. So our other quotient rule is, if I've got x to the a over x to the b, this could also be 1 over x to the b minus a. I'm still subtracting. It's just this time I'm following the larger exponent. So, for example, say I've got h cubed over h to the let's do 5th. Actually, that's a 5. H to the 5th. This is going to be 1 over h to the 2nd power. And again, our thought process here is very much like a fraction. I'll have h times h times h over h times h times h times h times h. And what is left over in the numerator will be 1. I'll have 1 times 1 times 1, which is 1. Down here, I'll have 1 times 1 times 1 times h, which is h squared. So I'll have 1 over h squared. So when we're looking at this, keep track of where you have the most of your terms multiplied together. They're going to stay there. Pause and let folks write some stuff down. And let's do a couple examples of this, and I'm going to use that to lead us into some new rules. Well, let's say I've got I'll just start with things like, I'll do x to the 7th divided by x to the 5th. Okay, 7 minus 5, that's just going to be x to the 2nd power. All right, let's do it again. Let's say I've got m cubed over m to the 12th. Oh, 12 minus 3. I've got my higher power in the denominator, so that's going to be m to the 9th down below. I'll still have a 1 up top. Okay. Let's do it again. Let's say I've got, I'll do this with some whole numbers now. I'll do 7 to the, I'll do 7 to the 6th power, and I'm going to divide this by 7 to the 5th. Oh, that's just going to be 7 to the 1st power over 1, which is just 7. All right. And, well, here that's bigger. Here, what happens if my denominator is bigger? Let's say I've got 3 to the 4th over 3 to the 7th. Okay, that's going to be 1 over 3 cubed. My higher power down below, which means that's where that term is going to stay, and we should evaluate that. So this is going to be 3 times 3 times 3 is 27. 1 over 27. There's that answer. Well, what happens if I've got something like, say I've got 5 to the 4th power over 5 to the 4th power? No, that would be 5 to the 0. But notice that this is just a thing divided by itself. That's going to be equal to 1. And this right here is the reasoning behind what we think of as the zero exponent rule. The zero exponent rule basically says that anytime you've got a base to the 0th power, as long as it's a non-zero base, your answer is going to be 1. And as we showed before, if I've got 5 to the 4th over 5 to the 4th, this is just, that would be equivalent to 5 to the 0. 4 minus 4 is 0. But the other thing to keep in mind is a thing divided by itself is 1. 5 divided by 5 is equal to 1. And 5 to the 4th, 625, by the way. 625 divided by 625 is also 1. Oh, so it'll just have 1s over 1s. 1 times 1 times 1 times 1 divided by 1 times 1 times 1 times 1. This is all equal to 1. And this is the source of many a dirty trick that math teachers love. So I could do something like say, oh, I'll start with the easy ones. I could say, x to the 0. Oh, that's 1. I could have 7/5 to the 0th power. Oh, that's 1. I could have something big and exotic. I could have, 3x to the 7th over 19t to the 12th. All of that to the 0th power. That's 1. Now, I said this is a source of many a dirty trick. Here is where the dirty tricks come in. I could have something like 3y to the 0th power. This is going to be the same thing as 3 times 1, which is 3. So remember, exponents only apply to what they touch. They are not going to apply to any coefficients or any other terms other than what they're on. Very briefly, I want to touch on some rules for negative exponents, and I think this video is long enough, so I'll pause it right here. But with negative exponents, we could just as easily say, if I had x to the 3rd over x to the 4th, I could still do 3 minus 4. And that would be x to the -1. But if I keep this in place, 4 minus 3 is just x to the 1. Anytime I've got a negative exponent is equivalent to taking the reciprocal. So our first negative exponent rule So our negative exponents do this. If I've got x to a negative exponent, this is just going to be 1 over x to that power. Only notice that when I take that reciprocal, I've made that a positive power now. If I've got 1 over x to a negative exponent, again, this is just going to take the reciprocal. I'm going to flip this fraction. So that's going to be x to a positive, same power. And if I've got a term inside a set of parentheses, I've got x over y to a negative exponent. This is going to be the same thing as y over x to a positive exponent. So the main impact of a negative exponent is taking the reciprocal. So we're literally just flipping these terms just like they were fractions, because we can, even if I don't have a term that is over 1, I can treat it as such. All right, that's all I've got for right now. I will see you in the next video.